section 7.1 talks about inverse, sine, cosine, and tangent functions. So inverse, before we do the inverse in trigonometry, we recall stuff from algebraic inverse. We did algebraic inverse. So if you have a function f, we used f to the negative 1 as its inverse. This is just a notation. This doesn't mean 1 over f. That's just a notation for the inverse. What did we do when we did the inverse functions in algebra? We proved that f inverse of f of x is always x for all x in the domain of the function. We also proved that f of f inverse of x is always x for all x in the domain of f inverse. Other things, we showed you that the domain of the function is the same as the range of the inverse, and the range of the function is the domain of the inverse. These are the things that we learned before. So other things we learned is that to find the equation of the inverse, we do two things. We switch x and y, and solve for y. These are the things that we did, we covered in inverse functions in algebra. Good to keep those in mind because we're going to use them in this section, but for trig. So let's start with the first function, y equals sine of x. What we need to know about sine inverse? So sine inverse, I'll show you the notation for that in a minute. Sine inverse. To get the sine inverse, let me recall the graph for the sine itself. If you remember, it was a 2 pi here, pi, 0, pi over 2, 3 pi over 2. So there was a 0, 0. There's a 1 here, 0, negative 1, and 0. So it went this way. So that was the graph of the function, and then it keeps going on both ends. Now, in order, if you remember, this function is this has no inverse. In fact, this has no inverse. In order for the function to have an inverse, it has to pass the horizontal line test. Which means if you draw a horizontal line, it must cross the graph at most 1 point, no more than 1 point. But if we draw a horizontal line, that's going to cross the graph at more than 1 point. So what do we have to do in this case to get an inverse of this? We pick an interval. Say I'm gonna choose this one. That's the most common ones. The highlighted part or section or interval or curve, this part has an inverse. Let me redraw it here. Okay, let me redraw it here. So I'm gonna make it a little bit bigger. It's pi over 2 and 1. So let's say this is pi over 2, which is a little bit more than 1. And we got a negative 1 and negative pi over 2. So it starts here at this point. It goes through the origin and goes up to that point. So it goes this way, up this way. That's the graph of the function sine that I need. So in this case, I'm going to say y equals sine of x. The domain for the original function here was, for this one, x was between negative into infinity, and y was between negative 1 and 1 inclusive. For this one here, the domain x is from exactly negative pi over 2 to pi over 2, and the range, the y, exactly from negative 1 to exactly 1. That's for the sine. This one has an inverse, this part, because if you draw a horizontal line across this, it crosses the line at exactly 1 point. So now we introduce the inverse. We say y equals sine to the negative 1 of x. This is sine inverse of x. This means sine y equals x. It means sine y equals x. So that's the what it means to say sine inverse. And in this case, notice how the domain for the function for sine was this. that will become the range of the inverse. So then the y of the inverse will become from negative pi over 2 to pi over 2. And the range for the function becomes the domain, becomes x. Keep in mind, x means domain, y means range all the time. Y for the range on the side. So now how do I graph the function and its inverse on the same graph? Let me redraw the graph again. So I'm gonna graph sine of x. This is pi over 2, negative pi over 2, and we got the 1 and negative 1. So there's a point here, here, and there. So it went this way, up, this way. That's the graph of the sine. Y equals sine. Now the inverse, what happens is this. So let's say, actually, I don't need the table for here. Let's do it this way. The points that we used were pi over 2 comma 1. In the inverse, this is for the function. For the inverse, it becomes 1 comma pi over 2. The 0, 0 is going to become 0, 0. The next one, negative pi over 2 comma negative 1 is going to become negative 1 negative pi over 2. So to graph that, 0, 0 stays as is. 1 pi over 2, so 1 here and pi over 2 is higher, somewhere here. And negative 1 negative pi over 2, somewhere here. Somewhere here. So then let me just draw this in a more accurate way. And now I'm gonna try to graph the next one. The next one is gonna go up this way, up. That's the inverse. That's sine inverse of x. Y equals sine inverse of x. Always, any function we have and its inverse are always symmetric with respect to y equals x, the line that goes through the origin in the middle. This is y equals x. Y equals x. See, it's not like exactly what you need, but because we're doing it by hand. So that's fine. That's fine to get it this way. So pay attention to several things. So again, for y equals sine inverse of x, the domain for this, as you can see the green one, it's from negative 1 to 1. So that's the domain, negative 1 to 1. And range from negative pi over 2 to pi over 2. Very important to keep in mind. Now another way to say sine inverse, some people call it arc sine. So they mean the same thing, arc sine, all together, one word, arc sine. So that's the inverse of sine function. Now, what does it mean when someone asks you find or determine? So let's say find sine inverse of 1. Like, what does that mean? Well, this is asking what is the angle its sine is 1. So kind of like backwards. So I would like to find the smallest angle that its sine is 1. Smallest positive if possible, that its sine is 1. Which one? Which sine of what angle? What angle goes here gives me 1. And we should know from before that that is 90 degrees or pi over 2 radians. So that tells me that sine inverse of 1 is really pi over 2. And this can be tested or checked on the calculator. There is a video that I uploaded also on YouTube for the use of the calculator for this class or for a trig class. So you can check those videos and you will see that. Other examples, let's say sine inverse of 0. So which angle its sine is 0? There's many ways. If you like, you can write this if you like. Let m equals this if you like to write this way. then sine m, by definition, is 0. So what is m? 0. M is 0. So this means sine inverse of 0 is 0. So the angle that it's sine 0 is angle 0, 0 degrees. What about another example? Sine inverse of negative 1/2. What does that equal to? What angle its sine is negative 1/2? Again, you can let's say alpha is sine inverse of negative 1/2. Then sine alpha is negative 1/2. Sine alpha is negative 1/2. Which angle its sine is negative 1/2? So maybe you want to start looking at on the unit circle, and you might say, well, the first angle that I can come across that is negative 1/2 its sine somewhere. So forget about the negative. So that's how I do. I forget about that negative. Which angle is sine is 1/2? Well, that's 30-degree angle, or pi over 6. Okay, so the first angle, if you travel this way, the positive direction, the next one that is negative is going to be here. It's going to be pi plus pi over 6, which is 7 pi over 6. So if you put that in here, guess what's going to happen? That's not going to work out. That's not going to work out. Why is that? Why is that? So I'm trying to find the y value. Back to the conditions. The y value, so I'm going to box this in red. The y value must be between negative pi over 2 to pi over 2. So any y value you get, you need to make sure those values, they fall between negative pi over 2 and pi over 2. So for this specific one, that's the first time it hits the negative 1/2. And the other one would be here. That's negative pi over 6. So our work for the values of sine inverse, for the y values, it has to fall somewhere here. From negative, this is negative pi over 2 all the way to pi over 2. So all the values that you obtain, they must fall within that shaded region. So in this case, alpha must be negative pi over 6, not 7 pi over 6. Okay, not 7 pi over 6, because it doesn't fall in or fulfills the condition, or it falls between negative pi over 2 to pi over 2 inclusive. So we can also, more than that, we can say that the inverse of f of x, which in this case sine inverse of sine of x, we can say this is x. This is x, provided that x is going to have a condition. What is x going to be? The conditions on x, they will always follow whatever you have inside. That's how I memorize it. These conditions. So what do we know about sine x? Let's go back up to sine x. This is sine x. The x was from negative pi over 2 to pi over 2. That's how, it's a good way to memorize it. So from negative pi over 2 to pi over 2. What about if I switch it? So if I do f of f inverse, this would be sine of sine inverse of x, and this is x. Now again, what are the conditions on x on this? X between negative 1 and 1. So keep that in mind, that these two things, they work only if x for the first one falls from negative pi over 2 to pi over 2, and the other one only when x is between negative 1 and 1 inclusive. Let's look at some examples. Find the value or the exact value of each of the following. Let's say sine inverse of sine pi over 16. Let's see, how does that look like, the first or second? It looks like the first one. Does that equal to x? Is this value they give me, this is the x value. Is that between negative pi over 2 to pi over 2? Yes, it is. So I can simply say this equals pi over 16, which is in the interval negative pi over 2 to pi over 2. It's fine. This is okay. What about another example? Sine inverse of sine 5 pi over 4. What does that equal to? Okay, so this looks like the second one. So can I say that's an x? Where's the x? This is the x value. Is x between -1 and 1? No, that doesn't look like that one. It looks like the first one. Is x between -pi/2 to pi/2? Oh, it's not. It's not in -pi/2 to pi/2. So what do we have to do in this case? It's more than pi. Actually, I wanted to do let me change the example to a slightly different example. Let's say I want to do 6 pi over 7. 6 pi over 7. So now, is that in that interval? Like, how can we tell if it's from -pi/2 to pi/2? There's many ways to do this. One way you can convert, if you like, the 6 pi over 7 into degrees and see what you get. So we can convert that into degrees, if you like. How do you convert that to degrees? Or you can say this is a little bit, it's not exactly 7 pi over 7, which is pi, a little bit below pi, if you want to think about it that way. Or as I said, you can multiply by 180 over pi to convert it and calculate this is about 154 degrees. So that tells me this angle is somewhere here in the second quadrant, because that's 180 or pi radians, pi/2 or 90. So we were hoping that it's somewhere in here, but it's not. So this is the 6 pi over 7. Now, how do I find the other angle? How do I make it look in this first quadrant or fourth quadrant? So this is quadrant 1, quadrant 4. It must be in one of these. So how do we manage this? So we do, the whole angle is pi. So if you do pi minus 6 pi over 7, that's pi over 7. So this angle here is pi over 7. So what do? We draw the kind of like symmetry. So that would be the pi over 7 here. So we call it the supplement of that angle. So the pi over 7. So this means I can rewrite this as sine inverse of sine pi over 7. And then now this falls from -pi/2 to pi/2. Then I can say this is exactly pi over 7. So that's something that easy to miss on the test or homework for students. So pay attention to it. In which quadrant does the angle fall, and make sure if it's not in the first or fourth, you either move it to the first quadrant or the fourth quadrant. Now that's for sine inverse. We can do the same for cosine inverse. So if we have y equals cosine inverse of x, this means, like as a definition, x equals cosine y. X equals cosine y. What are the conditions on this function? Well, let's see. I'm going to graph y equals cosine. Not the entire one, but I'm going to just take it over just all the way to pi. This is pi/2, 0, and there's a 1 here. And -1 down there. So it starts at this point, it's going to go through 0, 0, pi/2, 0, and then down here. So it's going to go down this way. That's for the cosine. Notice how this passes the horizontal line test. Now to get the inverse of this, look at the point 0, 1. That's for the function. And I'm going to find the inverse of that. Pi/2, 0. So this becomes 1, 0. Switch x and y. Switch x and y. And the last one was pi comma 0, -1. Pi comma -1. So that gives us -1 comma pi/2. So let's see what we get. 0, 1 becomes 1, 0. So it's going to become somewhere here. That's the one. Pi/2, 0 is 0 pi/2. So that's going to go somewhere here. Pi/2. Pi -1, so it's going to be -1 pi. So we need to extend this a little bit higher. higher. So that gives me, that's a -1, and the pi, let's say the pi is here. So it's gonna be somewhere there. So it's gonna come down through this. So this is the function cosine x, y equals cosine x. This is the inverse, y equals cosine inverse of x. So the way I graphed it, that's the easiest way. And notice, as we said earlier, if you draw the line through the origin, y equals x, the two functions are symmetric with respect to y equals x. So y equals x is kind of like the mirror. So if you fold the paper along this line, it will, the two graphs, the black and the green one, will coincide with each other. Okay, so what are the conditions here that I'm gonna write for the inverse? For the inverse, for this one, x, notice how x between -1 and 1, and y, the y, it starts exactly at 0 all the way up to pi. So I'm gonna box them in red because I feel those are important. Okay, so that's what we have about the graph and the conditions on the inverse. So now let's try to find, if we are asked find the value of each of the following. Let's say cosine inverse of 1. What is the angle? It's cosine 1. From the unit circle, you're gonna find it's really 0. For the next one, what's cosine inverse of -√3/2? What is the first angle you come across? Its cosine is -3/2. That would be 5 pi over 6. All this from the unit circle. Cosine inverse of -√2/2. If you check it, or if you should know it, it's 3 pi over 4. 3 pi over 4. Now what we have, f inverse of f of x is the same as cosine inverse of cosine of x. And this is equal to x only under the conditions of cosine. So cosine, I graph the cosine from 0 to pi. So 0 less than equal x less than equal to pi. And f inverse of x is cosine inverse of x equals x, and that goes from -1 to 1. Very important stuff to know. And to apply those things, we can go through some examples. Find the exact value of number 1, cosine inverse of cosine pi over 8. Okay, so first thing we look at is, does that match the first or second one? It matches the first one. So the x value is this. This is the x. Is the answer x? Well, it depends. Does x go from 0 to pi? Does it fall in there? Yes. So then it is x, or in other words, pi over 8. Since pi over 8 falls is in 0 to pi. So that's fine. What about another example? Number 2. Cosine inverse of cosine of -3 pi over 4. -3 pi over 4. This is the x value. Does that x value, let's see, does it look like the first or second? Looks like the first. X must be between 0 and pi in order for us to use this property here. So does x fall exactly from 0 to pi? Well, it's not. It's somewhere in the negative. So what we have here is this is somewhere here. But it says it must be somewhere in the first two quadrants, somewhere here, in order for us to use the property. So now, what do we have to do in this case? Well, it's very simple process. All you have to do, as we did before in sine, is kind of like use the symmetry stuff. That's the 3 pi over 4. So we can replace x with, or the negative, with 3 pi over 4. And in this case, that becomes 3 pi over 4. And which is in 0 to 2 pi. Another one, find cosine inverse of pi. cosine inverse of pi. This would be like the trickiest on a test. So let's see what we get for this. Let's see what we get for this one. The first thing to do is check the x value. This is the x value. Okay? The x value is pi. So the x value is pi. So what we're going to do is check which one does that fall in. Does that fall in the first one or second one? The second one, so that's like second one, because second one here, it starts with cosine. So that says only this equals x, only under that condition, x between -1 and 1. Is x between -1 and 1? No. X equals pi, not in -1 and 1. And I can't do anything about this value. So this has no value, you can't find it. And if you put it on the calculator, try to put on the calculator, making sure the mode is radians, it will give us an error. It will give us an error. So now, let's look at the tangent. Y equals, that's the next one, tangent of x. And to graph this, I'm gonna take the graph of tangent from pi over 2. If you remember, there's a vertical asymptote at -pi/2. So the x here from -pi/2 to pi/2, excluding those points, -pi/2. And the graph of tangent was like this. That's the graph of tangent. So this is y equals tangent x. Now how do I graph? This was x equals pi/2. How do we graph the inverse? This was x equals -pi/2. And it went through 0, 0. So this is how we graph it. Remember, to get the inverse, we switch x and y. So instead of x equals pi/2, it's going to become x equals pi, y equals pi/2. And the inverse for -pi/2, y equals -pi/2 for the inverse. It went through 0, 0. It's going to also go through 0, 0. Okay, so it's going to go like this and up. So in the middle here, we got y equals x. So the blue one is tangent inverse. Y equals tangent inverse of x. So by definition, y equals tan inverse of x means x equals tangent y. Now for the inverse, for y equals tan inverse, what are the restrictions? Notice for the blue curve, x goes from -infinity to infinity, so x can be anything. But the y has to be from -pi/2 to pi/2. Box them again. And this one, you can write it as arctangent of x. Good to know that. Good to know that. Now we're going to look at several examples on this. Some examples on this. How do we calculate or find tangent inverse of 1? And then we're going to look at tan inverse of -√3. Okay, let's see. What's the first one? What's the angle between -pi/2 to pi/2 that has tangent 1? We know it's pi/4. Pi/4. For this one, which angle is tangent is -√3? I know without the negative, it's 60 degrees. Okay, 60. But since there's a negative, we use -60 or -pi/3. Note that this is in the interval -pi/2 to pi/2 because of this. Remember, the y value must fall between -pi/2 to pi/2. Here, when we do -pi/2 to pi/2 is this one, as we did in sine. The only difference between the sine and this one does not include the bounds, does not include -pi/2 to pi/2, does not include these two bounds. It's only below pi over 2 and bigger than negative pi over 2. Again, keep in mind that f inverse of f of x, which is tan inverse of tan x, this equals x, provided that x from negative pi over 2 to pi over 2, and f of f inverse of x is tangent tan inverse of x, which is x, provided that x can be anything. So that's all introduction to inverse functions. If you remember how we did in algebra to find the equation of the inverse, we switched x and y and we solved for y. We can do the same thing here. Find the equation of the inverse. Find the equation, the inverse f negative 1 of this function. Let's say f of x equals 3 cosine x minus 2, provided x from 0 to pi. So how do you find the equation of the inverse? 2 steps. Switch x and y and solve for y. So this means is exactly y equals. That's what f of x means. Switch x and y. So x equals 3 cosine y minus 2. I switched x and y. And now how do we solve for y? The first step is add 2 to both sides. Divide by 3. And to solve for y equals cosine inverse of x plus 2 over 3. Okay, so that's the inverse. That's the equation of the inverse. So again, switch x and y and solve for y. Switch x and y and solve for y. So, let's say, look at another example. So how do we, solving equations like this, that's good enough, just switch x and y and solve for y. This works for sine, tangent, and cotangent the same way. Let me add more parts to this. Let me add more parts to the same problem. For the same one, find the range of f. What was the function? 3 cosine minus 2. Without, let me write it down, without graphing. We can't graph. So what do we do in this case? How do you find the range of this without graphing? So we need to find where does the y value change? Where does it change from where to where? To find the y value, so what I'm going to use this in a tricky way. So let me rewrite it in terms of y. So 3 cosine x minus 2. Watch how I'm going to do this. I'm going to find the range of this. I want to know where the y falls. I'm going to add 2 to both sides. I'm gonna solve for cosine x, and you will see why in a minute. So divide by 3 both sides. We got this one. Now I'm gonna use this one. We know that cosine x always between exactly negative 1 and 1. So the graph of it is always between negative 1 and 1. But cosine x is y plus 2 over 3 from the equation above, like at the bottom, at the top of this page. Now I'm going to solve for y. Multiply everything by 3. Negative 3 less than or equal y plus 2 less than or equal to 3. Subtract 2 from all the sides here. I got y to be negative 1 to 1. So that's the range. That's the range is from negative 5 to 1. Because the range means the y values. So this was for the function. Range of f. That's the range of f. What about if they ask us to find the domain of f inverse? What does that equal to? Well, when we started the lesson today, we said that domain of the inverse is the same as the range for the function, which we just found. Right? What about if they ask us to find the range of the inverse? What's the range of the inverse? Again, think about this way. Range of the inverse is the domain of the function. But what is the domain of the function? We don't know what the domain is. Let's go back to the original problem. Oh, they give it to us from 0 to pi. So that would be the domain of the function is the range of the inverse. So that would be 0 to pi. So those are quick applications when we talk about functions and their inverses. What can be other applications here? Maybe they can ask us to solve the equation. Let's say the first one is 2 cosine inverse of x equals pi. How do we solve such equation? Well, first we solve for cosine inverse is pi over 2. And then ask yourself, you can rewrite this if you like, as by definition, x equals cosine of pi over 2. The first angle you come across, pi over 2 is 0. It's cosine pi over, the cosine pi over 2 is 0. So that's how we solve it. Another example, let's say we were asked to solve 4 cosine inverse of x minus 2 pi equals 2 cosine inverse of x. So how do we solve such equation? To do so, we subtract 2 cosine inverse of x. Subtract 2 cosine inverse of x. These cancel, so you get 2 cosine inverse of x minus 2 pi equals 0. Then we add 2 pi to both sides. I want to isolate the cosine. So cosine inverse dividing by 2 gives me pi. That means x is cosine pi. And what is cosine pi? -1. So that was all introduction to trigonometric inverse functions, and especially sine, cosine, and tangent. Sine, cosine, and tangent. There's a lot of conditions here, but it's just a matter of practice. When you go through all this again, you will find that this shouldn't be that difficult. And the more you practice, the easier this gets. So again, just keep in mind, if we have y equals cosine inverse of x, you can write this as r cosine of x. They mean the same thing, just different ways of writing.